In lesson 5.3, we're talking about one-sided limits. So what we do is we look at the limit from the left side, from the left, and then we look at the limit from the right, and we want to make sure that they're the same value, the same limit. And if they're the same, then we can say the limit of the entire function is whatever that number is. So let's go to Desmos and type in this function. All right, we're going to do absolute value, which is here, 2x divided by x. And when we look at our function over here, this is what your graph looks like. So I've got a horizontal line going to -2 on the left side of 0. And on the right side of 0, it's a horizontal line at +2. And so I would say my left-hand limit, as we go towards 0 from the left side of the graph, it's going towards -2. And the right side of the graph, the right-hand limit, as we go towards 0, is going to +2. And so the overall limit does not exist. So we would say, if we're looking here, it goes to -2. Over here, it's going to +2. So the limit as x approaches 0 from the left, we put a little minus sign in the top corner to say that we're going from the left of our function is -2. And the limit as we approach 0 from the right, we put a little plus sign. So the right side of the function was going to +2. And because these are not the same, the limit does not exist. They have to match. The left and the right have to be the same. Let's go ahead and put example 2 into Desmos. All right, if you want to do piecewise functions, you just write your equation, and then you put a brace, and then you put the inequality. So this says less than 1. And then this one is x is greater than or equal to, and that is here. Okay, so this is what the graph looks like. And it says that we're approaching 1 in the notes. So here's 1, right here. And it's undefined for the red. It should be defined for the blue. So if I go from the left side, it's a straight line, and it's going down towards 4. No, down towards 3. 1, 2, 3. And the blue line from the right side is going up, and then it goes back down, and it's also going towards 3. And so both sides of the graph went towards 1, 2, 3 for the y value. So that would be the limit. So I would write this as the limit as we approach 1 from the left was +3. The limit as we approach 1 from the right was also +3. And since those are the same, we say the limit as x approaches 1, and we don't put a little plus or a minus because it means from both sides, is 3 because they are the same. Example 3. An overnight delivery service charges $8 for the first pound and $2 for each additional pound. Let x represent the weight of a parcel and let f of x represent the shipping cost. Show that the limit of f of x as x approaches 2 does not exist. So here we're seeing that the delivery charges $8. That shows you that even if, and it says for the first pound, even if it doesn't weigh anything, it's still going to cost you $8 to send, and it does say greater than 0 because you're not going to send anything that doesn't weigh any pounds. And then it says for each additional pound, it's $2 more. So we see if it's above 1 pound, if it's anywhere between 1 and 2, it's now $10. If it's anywhere between 2 and 3, it's now $12. So every time we add $2. If we want to look at a graph of that, you can go to Desmos, you can go to Desmos like you had before and do the inequalities, or you can think about what the graph would look like on your own. Let's do it on our own right now. So the value is 8, 10, and 12. And it says from 0 to 1, we've got 8. So from 0 to 1, it's 8. And I put an empty point on 0 because there's no equal to sign, and a filled in endpoint at 1. And then I've got 10 from 1 to 2, so that's going to be empty, filled in. And then it's 12 from 2 to 3, so empty on 2 and then filled in at 3. So this is what that graph looks like, only it should be evenly spaced out, the 1, 2, 3. And it wants to know what is the limit as x approaches 2. So we're focused right here in the graph at x equals 2. We see on the left side the line is at 10, and so the limit is 10. On the right side, the line is up here at 12, so the limit is 12. So the limit at 2 is not going to exist because they're not the same. And so we would say the limit as x approaches 2 from the left for the function is 10. The limit as x approaches 2 from the right is 12. And since they are not the same, then the overall limit does not exist for the limit approaching 2. It has a left-hand limit, it has a right-hand limit. Those are correct, but it doesn't have an overall limit at 2. Example 4 is a completely new type of limit problem that we're seeing for the first time. They've given me a function, and then they've asked me to do this with it. So we're just going to kind of plug in what they want. It says the limit as h approaches 0. That's just going to be written down. F of 3 plus h. So this is just function notation. It wants you to plug in 3 plus h in for your input variable. So I plugged in 3 plus h for the x value. Then it says minus, so put a big minus, f of 3. So now they want me to plug 3 into the function. So I'm going to plug in 3. Put parentheses around it because when you subtract, you have to distribute. And it says all over h, so put all over h. So make sure you can read this and know how to fill it in like I just did. Then we just go through and we simplify. So if I FOIL, I'm going to have to FOIL this. It doesn't distribute, you have to do it twice. So that'll be 9 plus 6h plus h squared. That's that first part. Then minus, and then this is going to be 9 minus 1, so that's 8, and then all over h. Then the negative 1 and the negative 8 are going to make negative 9, which cancels out the 9. So now I've got 6h plus h squared all over h. On top, you can factor out an h so that we can cancel the h on the bottom. Okay, so I factored out an h on the top because they both had one in common, and now it's canceling with the bottom. And this is as simplified as I can get it. And then it's time to do the limit. So the limit, it says h is going to 0, so if we just plug in 0, we get 6 plus 0, and the answer is 6.